to thank the guests from the Current Challenge for being here. And I'd especially like to thank the panel for coming and helping our teams out. As you know, they are mostly engineers. They've been studying venture capital pitches. They'll be giving a venture capital pitch today. I would like for you to be as critical as you think you need to be, because this is a trial run. So this is the time to be critical. Today we're going to hear from three. I'm very excited about the groups. They've done fantastic. I think you'll be impressed, but I'll let you make that decision. We're going to hear from three groups. We have three in the class. The first group will be water link. The presentations will be about 20 minutes with 20 minutes for questions. So water link, please.
Right, so hi everyone. I'll just let everyone introduce themselves. I'm Neil Kulkarni.
I'm Pete Daniels.
I'm good.
I'm Pete Daniels, a grad student in environmental engineering.
Erin Hubbard, MBA student and civil engineer.
I'm Katerina Grande, a global environmental health student within the School of Public Health.
I'm an undergraduate chemical engineer. Okay. Alright, so thanks for being here. We'd like to discuss the water scheme that we have researched and implemented for the region of Dharavi in the city of Mumbai, India. So I'd like to talk you through that today. So I'd like you to imagine a scenario where it's going to be 95 degrees outside today. It's been hot and humid for the past 2 months. And it's 5 a.m. in the morning, you've got 12 hours of work ahead of you, laborious work, and you have no water.
You have to fetch the water, but the tap is 20 minutes away, and yesterday when you got there, they were charging, even though it's supposed to be free.
So the question is, how long would you wait for water? People in slums such as Dharavi have to stand in line for approximately 3 hours every morning before 6 a.m. in order to get their daily supply of water. So this mainly happens because of infrastructure constraints. There's not enough water to supply the whole of Mumbai. The municipal corporation supplies water to these areas through taps, and these taps are only available for about 3 hours each morning. So in a nutshell, there basically is not enough water for the slum residents. Now, Mumbai gets its water from rainwater-fed lakes, and then this water is supplied by the municipal corporation of Mumbai through the whole year. It's distributed and it's rationed and supplied to the entire parts of the city. The slums, because of economic and infrastructure constraints, get only 1/5 of the amount of water that the rest of the city gets. So these are the main forms in which water exists in the slums. As I mentioned, the tap water is where the water comes into the slum. Then we have domestic and household wastewater, which empties into the drains in the same area. We have small-scale industries in the region, which include a leather industry, a pottery industry, a food production industry, a recycling industry. So all of their wastewater also enters the same drainage in the area. We have an artificial source. Sometimes when there is severe water shortage or the taps aren't functioning, tankers bring water from outside the region. This is very expensive and a temporary solution. So what we have decided to focus on is rainwater harvesting. Now, Mumbai gets a torrential monsoon season between May and October.
Three times as much rainfall occurs in Mumbai than it does in Minneapolis, and this occurs in just half as much time. The potential for rainwater harvesting in this area is substantial.
So India, a country of 1.1 billion people. Mumbai is the financial capital of the country, similar to what New York is to America. So one of the most densely populated cities in the world and one of the biggest cities in the world, Mumbai is on the western coast. The region we are focusing on in Mumbai is in the geographical heart of Mumbai. It's called Dharavi, which is popularly known as one of Asia's largest slums. Within 1 square mile, you have approximately 1 million people living in this area. Extremely congested. As I said, it's at the heart of Mumbai. It's very close to the ocean on the left. And the economic industries include the leather. So there are many small-scale industries, many houses in this area for 1 million people. So what does it mean when I say living in a slum? Now, what are the characteristics of living in a slum? It's extremely crowded, noisy. It's a very small area for you to live in, which means there's about 5 to 10 people in areas as big as 2 bedrooms. There's sewage flowing right outside your house, and you do not have any windows to block out the smells. So taking a walk through these slums, which I've learned myself through experience, it can be a very humbling and eye-opening experience, because basically you learn to see what type of luxuries we live in here in America, or even in the rest of Mumbai. They call this home. The drainage possesses a large amount of waterborne diseases, so it's extremely hard to live in these conditions, as in your health-wise. And for the water, the utilities are in extreme shortage also, electricity and water especially. Now, as you can see on this graph on the right, the Dharavi resident gets approximately 1/10 of the amount of water that an American resident gets every single day, and approximately 1/5 of what the rest of Mumbai would get if you're not in a slum.
Unfortunately, we weren't all able to travel to India, and so what we did is try to identify ways that we could really leverage our resources and investigate what was really happening within these slum communities. We did this in a variety of ways. We have Indian counterparts, and they were able to go into the slums and interview residents regarding their daily life and what's going on, problems that they're facing. We also were able to find printed interviews that were published, and the final source that was really helpful to us was photographs, those both taken by our counterparts, others who traveled on behalf of ACARA, and then just widely available photos on internet sites. What we learned is that water is the center of daily life in this region. Specifically, of course, women and children bear the burden substantially for gathering water. And we're going to go on to the next slide now. We also found, which was very surprising to us, that the problems that are happening in the slums are not actually issues of water quality. Specifically, it turns out that water is not widely available. Only 75% of the water need for residents within all of Mumbai is met according to the municipal corporation. And of course, we know that that rate or percentage is actually much lower within slum areas. So again, just the takeaway from this is that we're really concentrating on getting water quantity, not so much water quality. We also found that this is a complex place. We have no idea just how crazy it might be to live in this area. Of course, not everything was planned. Water supplies and infrastructure were built before a lot of the people arrived, and now people are still arriving. NGOs are trying to work within the area. Small companies, as we've alluded to, are quite busy as well. And so we really wanted to try to find a way to bring a collaborative approach to our solution. We understood that this would allow us to really leverage our resources and do more for the community.
Right, so as I mentioned, I'll elaborate a little bit more on each of these water existing forms. So the tap water which comes from the BMC, BMC is the Brihan-Mumbai Municipal Corporation, that's the governing body for all the utilities. This tap water is available only 3 hours a day in different areas of Bombay. Now, middle class apartments have their own big tanks in which they store the water for 3 hours, and then they are able to use this water the entire rest of the day. Dharavi does not have such resources. Tap water is available only from 6 to 9 in the morning or 5 to 8 in the morning. You have to stand in line over there. And you need a lot of government influence in order to change this amount. And it's practically impossible because of the constraints that they have by infrastructure. So we rule that option out. Household chores involve cooking, bathing, washing, cleaning. All these activities take place outside the 2-bedroom house that they have. Right next to the houses there are tiny drains in which the water basically runs off. So in order to stop this, in order to collect this water, it would be an extremely big behavioral change on the part of the people that do this. They're very used to just doing their stuff and then letting the water run off. So we ruled that option out also. Now industrial waste. Dharavi has a huge economy in the tune of about $500 to $700 million. This includes the leather, the pottery, the recycling, as well as the food production industry. Now, all of these industries are small-scale industries operating in about 1 to 2 room basis in like about 10 people per industry. The effluents that they have from these areas are highly contaminated, and is once again a behavioral change, and it would require a very high level of sophistication in order to recycle and purify and recycle this water and bring it back to the Dharavi region for use. A very high level of sophistication, and it would be extremely cost prohibitive. So we ruled that option out as well. Artificially, of course, you can bring water in from tankers outside the region. This is extremely expensive. It's temporary. One-time costs are in the tune of 500 rupees, which is about $10 per trip. It's extremely expensive. So it's definitely not sustainable. Rainwater, on the other hand, as I mentioned, Mumbai has a torrential rainfall season between May and October. It's clean, it's free,